Okay, here are the conjectures for chapter 10. So the first thing for the Pythagorean theorem, we're going to highlight all three sides and measure their lengths. So I have side AB, side AC, and side BC. And then we're going to show how the Pythagorean theorem works. So we're going to go to number, calculate, and we will open the grouping or open the parentheses, and we're going to say a squared, or one leg squared, plus the other leg squared is equal to, so those two together will be equal to the number calculate will be equal to the hypotenuse squared. Okay, and as this moves around, you can see that those values hold true. Isosceles right triangle, what do we want to show? We want to show the relationship between the legs of an isosceles right triangle and the hypotenuse. So if I measure one of the legs and I measure the length of the hypotenuse, I want to show that the relationship between the two is I can take a leg and multiply it by √2 to get the hypotenuse. So we're going to go number, calculate. We're going to take the length of the leg and we're going to multiply it by the square root of 2. And you can see that those values are equal no matter how this triangle moves. 30, 60, 90, again, we want to show the relationship between the legs, so let's measure all three. CB, AC, and AB. And if I take my calculator and I take the smaller leg and I multiply it by 2, I will get the length of the larger leg. And if I take the smaller leg and I multiply it by the square root of 3, I will get the value of the longer leg. And you can see those hold true no matter the size of the triangle. The distance formula. So we want to find the distance between 2 points. If I highlight the 2 points and measure the distance, I can see that the distance from D to C is 4.92. Where that comes from, or the formula that we're going to use, we're going to say number, calculate, and we're going to take the square root of parentheses x1 or x2 minus x1 squared. I have to go back. I want to make sure the quantity is squared. Plus parentheses, and I went from D to C, so let's go D minus C, Y minus Y, and again we're going to square that, and there you go. So our distance formula, the difference of the x's squared plus the difference of the y squared equals the radius squared. So by taking the square root, we get the distance between the 2 points. Equation of a circle. To finish it up, here's our circle. As long as the circle is highlighted, we can measure the equation. So the equation of a circle. So as this gets bigger, the radius gets bigger. As I move this center, the location of the center changes.